Here's the answer for the SLO study guide. Problem number 1, compute the distance between the 2 points and then find an equation of the line through them. So for these types of problems, all you're going to do is use the Pythagorean theorem to find the distance. So I know that if I made a triangle, that 10 and 15, so 15 minus 10 is going to be 5. So the distance is 5, and then negative 6, this is going to be a negative 2. So when I do the Pythagorean theorem, I do 5 squared plus, negative doesn't matter for the distance, 2 squared equals c squared. 25 plus 4, 29 equals c squared. So I take the square root of both sides. So I get the distance is the square root of 29, or about 5.4. For the equation, so I already know the slope because I have the triangle, it's negative 5 over 2. So I do y equals negative 5 over 2x plus b. So I'm going to plug in one of the points. I chose negative 4, 10. So I get 10 equals 2 times 4. This is 10. Negative 10, negative 4, it's positive 10. So I get 10 equals 10 plus b. So b ends up equaling 0. So my equation is just y equals negative 5 over 2x. For problem number 2, start it the same way. I'm going to draw a triangle. Distance between 10 and negative 3 is 13. Distance between 2 and negative 6 is 8. So I'm going to do 13 squared plus 8 squared. So I get 169 plus 64, or 233. So my distance is the square root of 233, or about 15.3. So my equation, I already know the slope, 13 over 8, x plus b. I'm going to use 10 too. So 10 equals 13 over 8 times 2 is 13 over 4 plus b. Subtract 13 over 4 from both sides. I get b equals 6 3/4. So my equation is y equals 13 over 8 x plus 6 3/4. For problem number 3 and 4, find a solution to these systems. So for 3, I solved for x in the first one by dividing both sides by 2. So I end up with x equals 2y. And then in the second one, I substituted in 2y. So I got 2 times 2y plus y equals 2y divided by 2 plus 1. So we got 4y plus y. It's y plus 1. Subtract y from both sides. So I ended up with 4y equals 1. Divided by 4, I got y equals 1/4. So then I plugged it back in up here to find x. So x equals 2 times 1/4, which is 2/4 or 1/2. So my ordered pair is 1/2, comma 1/4. For 4, I used elimination, so I multiplied the bottom by negative 2. So I got 2x plus y equals 7. Negative 2x minus 10y equals negative 24. So I simplified these, canceled. I got negative 9y equals negative 17. So y equals 17 over 9. I plugged it back in, so x plus 17 over 9 equals 12. So I multiplied, and when I did that, I put 12 over 9. So I ended up with 85 over 9 equals 108 over 9. Subtracted 85 over 9 from both sides. Ended up with x equaling 23/9. So my ordered pair was 23/9, comma 17/9. Problem number 5, we write each expression without radicals or negatives. So negative exponent makes it go up or down. So this one's just going to be v squared. A square root or cube root or sixth root is just the fraction 1/6 or 1/3, whatever the root is. So this is already being raised to the 5th power. I just make it 5 times 1/6, which is 5/6. So this becomes 1/7 to the 5/6. For 7, they're both negative, so they're going to go into the denominator. So I get d to the 9th, d to the 4th, add those together, so I get 1/d to the 13th. For 8, everything goes into the denominator. And then I square everything, so I end up with 1/9x squared w to the 8th. Domain and range. So for 9 and 10, the domain for both of those are all real numbers because going the x-axis, everything continues to be the same. So both for 9 as well. 9, the range, it has to be above -5. So y is greater than or equal to -5. And for 10, it actually has to be above -2. So y is greater than or equal to -2. For 11 and 12, I'm simplifying functions. So in 11, I'm plugging in 3a for x. So I just get 3 minus 3a squared. So then I simplify that and I get 3 minus 9a squared. That's my answer. For 12, I know what f of x equals. So I set it equal to 0. So I factor it. So I get x plus 3, x plus 2 equals 0. So I know x equals -3 or -2. Okay, so for the next few problems, we're writing arithmetic sequences given two of the terms. So in problem number 13, we know that t of 61 equals 8. You can write it as an ordered pair. And then t of 94 equals 1,239. So you just treat it like an ordered pair. So first you find the slope, so you find the difference of those two, which is 429. And then you find the difference of 94 and 61, which is 33. And when you divide them, you get 13. So I know my slope is 13, so I just put it in my mx plus b formula. So I chose to use 61 and 810, so I plug them in. So I got 810 equals 793 plus b. So then I subtracted 793. And I ended up with b equals 17. So when I write it as t of n, I'm going to say t of n equals 13n plus 17. So for 14, I do the same thing. So my ordered pairs are 352 and 10108. And I find t of n, but then I also find t of 100. So I subtract these two and these two. So I get 7 on the bottom and 56 on the top. So my slope would be 8. So I'm going to do y equals 8x plus b. I'm going to sub in the 52 and the 3. So I get 52 equals 24 plus b. So I ended up with 28. So t of n equals 8n plus 28. And then t of 100, 8 times 100 is 800 plus 28 is 828. Okay, next problem I'm going to solve for y. So in this first one, I multiply both sides by 4 minus y. So then I get 4 minus y x equals 2. So when I divide both sides by x, so I get 4 minus y equals 2 over x. Add 4 to both sides. So I end up with negative y equals 2 over x plus 4, and then divide by negative 1. So I'm going to get my final answer, y equals, and you could either write it as negative 2 over x minus 4. Oh, you know what? I made an error. This should have been minus 4. So this makes this a negative 4. So it makes it a plus 4. So negative 2 over x plus 4, or I could say y equals 4 minus 2 over x. Either way is correct. So for 16, I'm solving for y, so I'm going to square it. Get rid of the square root, so I get y plus 3 equals x minus 2 squared. And then subtract 3. So I get y equals x minus 2 squared minus 3. So I can leave it like that because it doesn't tell me what form I can put it in, or I can multiply it out. So this is one answer. Or I could have said y equals x negative x squared, negative 4x plus 4 minus 3. So I would have gotten y equals x squared minus 4x plus 1. So this would be an answer too. So both of those are correct. Problem 17, multiply. So I'm just going to make a box. So I get x cubed, negative 4x squared, 7x, 3x squared, negative 12x, and 21. So my final answer is x cubed. These two added together equal x squared, negative x squared, negative 5x plus 21. Okay. For 18, I have to do it in two parts. So first, I'm going to figure out what x plus 1 times x plus 1 is. So I get x squared, x, and 1. So I'm going to get x squared plus 2x plus 1 times 2x plus y. So then I make an area model for that. X squared, 2x, 1, and then 2x and y. So I get 2x squared, x cubed, sorry, 2x cubed, 4x squared, and 2x. And then I get x squared y, 2xy, and y. So then when I write it all out, nothing can be combined. So I get 2x cubed plus 4x squared plus 2x plus x squared y plus 2xy plus y. And that's my final answer. Okay, problem 19, factor each expression. So remember, we're not solving, we're just factoring. So 3x squared times 4 is going to give me a 12x squared. And then negative 13x. So two numbers that multiply together to get 12, add together to get negative 13 are negative 12 and negative 1. So I get negative 12x and negative x. So in my box, I'm going to have 3x squared and 4. And negative 12x and negative x. So I know that this has to be 3x and x. 3x times negative 4 is going to be negative 12x. X times negative 1, and then negative 1 times negative 4 is 4. So when I factor it, I end up with x minus 4, 3x minus 1. So for 20, the first thing I can do is pull out a 2. So I get 2, 4x squared plus 12x plus 5. So then when I do my diamond and my box, I'm going to get 20x squared on the top and 12x on the bottom. So two numbers that add to 12 but multiply to be 20 is 10x and 2x. So I know that this has to be 4x squared, and this has to be 5. And then I get 10x and 2x. So let's see, so 2x times 2x and 1. And then 2x times 5 and 5. So it's 2x plus 1 and 2x plus 5. Problem 21. So I'm going to multiply. So I would actually factor everything. So I'm just going to write out what I would get. So that's the difference of 2 squares. So I would get x plus 4, x minus 4, x minus 4, x minus 4, times, it's going to be x and x, 6 and 3, negative and plus, and the bottom one, x and x, 6 and 4, minus and plus. So then after I factor everything, I can start crossing things out. X plus 4 and x plus 4 cancel. X minus 4 cancel. X minus 6 and x minus 6. So my final answer is x plus 3 over x minus 4. For 22, I'm going to do the same thing. For the top one, I have to flip them though. So I want to remember that I have to flip them. So I can factor out a negative 5. That way I end up with x minus 3. The bottom, I'm going to get x minus 3 plus 2. So I'm going to times it. On the bottom, I'm going to end up with 5x. On the top, I get x plus 4, x plus 2. So then I can cancel out the x minus 3s, the x, actually the 5s as well. So then I end up with negative 1 times x plus 4 over x. Okay, 23. I'm going to add. So I'm actually doing 6a minus a plus 1 over, I'm going to pull out an a, 5a plus 1. So when I simplify the top, I end up with 5a plus 1 over a times 5a plus 1. These cancel, and I get 1 over a. So 24. The denominators are the same again, so I'm just going to add. So I distribute my negative x squared plus 2x minus 10. X squared minus x squared, those cancel. I get 3x, so it gets 5x minus 15 over 10. So I'm going to pull out a 5. X minus 3 over 10. So these simplify. So my final answer is x minus 3 over 2. 25, find the x and the y-intercept. So in order to find the x-intercepts, I'm going to factor it. So after I factor it, I end up with y equals 2x plus 5 and x minus 7. So my x-intercepts are negative 5 over 2, 0, and 7, 0. My y-intercept is 0, negative 35. So the y-intercept, I just plug in 0 and I get negative 35. So for 26, in order to find the y-intercept, I'm going to plug in 0 and see what I get. Or actually, I'll multiply it out and see what I get first. So if I were to do an area model for the x minus 3x plus 4, I would get x squared, negative 3x, 4x plus x, minus 12, and then minus 7x equals y. So if I simplify this, I end up with x squared minus 6x minus 12 equals y. So my y-intercept I know is negative 12. I tried to factor that and it didn't work. So I know that I have to put it in the quadratic formula. So I get 6 plus or minus square root of 36 plus, because it's a negative 12, 48 over 2. So then I end up with 6 plus the square root of 84 over 2. So then I can actually just leave it like that. And my answers will be 6 plus or minus the square root of 84 over 2, comma 0. And I actually have 2 of them. Okay, problem 27, write each equation in graphing form. If needed, complete the square, then state the vertex, the y-intercepts, and the stretch factor. So I already know for 28 and 27, my stretch factor is 1, because there's no number in front of x squared. So for 1, I'm going to subtract 1 from both sides. So I'm going to end up with negative 1 equals x squared plus 5x. And then I'm going to complete the square by drawing my area model. I know that this is x squared. Half of 5 is 5 over 2. And then, so that makes it x plus 5 over 2. So that means that this is 25 over 4. So then I add that to both sides. So I end up with x plus 5 over 2 squared. And then negative 1 plus 25 over 4 is 21 over 4. So it's positive 21 over 4. So when I put it over here, it's going to be minus 21 over 4. So y equals. So my vertex is negative 5 over 2, comma, negative 21 over 4. My y-intercept is 1. So 0, 1. For 28, I also know my y-intercept, it's 0, negative 3. So this one I'm going to start by adding 3 to both sides. I get 3 equals x squared plus 2x. I complete my square. Half of 2 is 1, so these are both x. Just 1 here, so I add 1 to each side. So when I put it in graphing form, I get y equals x plus 1 squared. This is 4, so minus 4. So my vertex is negative 1, negative 4. Problem 29, I want to graph the inequalities. So I start with the first one. So it's positive 4, which is about here, and up 2 over 3. So this line is about like this. It's hard to see on the graph. And then positive 5, up 7 over 12. So my graph kind of looks like that. So it's greater than this one and less than this one. So I know that my answer is going to be between the two. So I just shade between the two. And you can use Desmos to see it a little clearer. For 30, I'm going to do negative x plus 2. So positive 2. It's going to be a negative. So it's going to be approximately right here. It's a solid line because it's equal to. And negative 6. It's approximately right there. So since it's less than both of them, so less than this one, my answer is going to be right here. Problem number 31, solve and check my solutions. So for problem 31, the first one is I'm going to add 7 to both sides. So I end up with 2, x minus 1 squared equals 8. Divide both sides by 2. So I get x minus 1 squared equals 4. Square root both sides. Oh, sorry, I'm going to go back to this one. I forgot to divide or multiply by 3. So let's start that one over. So I'm going to add 7 to both sides. So I end up with 2x minus 1 squared over 3 equals 8. So then I multiply both sides by 3. So I get 2x minus 1 squared equals 24. Then divide by 2. So I'm going to get x minus 1 squared equals 12. Take the square root of both sides. So I get x minus 1 equals plus or minus the square root of 12. And then I add 1. So my final answer is x equals 1 plus or minus the square root of 12. Problem number 32. I'm going to start by squaring both sides. So I'm going to get 5 minus m equals, when I multiply that out, I get m squared plus 2m plus 1. Subtract 5 and add m. Subtract 5 and add m. So I end up with 0 equals m squared plus 3m minus 4. So I factored it. Ended with m plus 4 minus 1. So I got m equals -4 or 1. So when I plug them back in, 5 minus -4 is 9. The square root of 9 is 3. But -4 plus 1 is -3. So -4 is extraneous. So the answer is just m equals 1. 33 and 34 are exponential equations. So a bond that appreciates 4% per year will be worth 146 in 5 years. Find the current value. So I know that 146 is going to equal A times 1.04 to the 5th power. So I put that in my calculator and got 146 equals about 1.22A divided by 1.22. So I ended up with about $120. 34, 60 years ago when Sam's grandfather was a kid, he could buy a friend dinner for $1.50. That same dinner costs $25.25 and inflation's consistent. Write an equation that models the cost for the dinner at any different time. So first we have to use Sam's problem to help us. So I know it's going to equal $25.25. $1.50 is my A. I don't know what B is, so I'm going to say B for the 60th. So I divide both sides by $1.50 and ended up with 16.83 equals B to the 60th power. So I take the 60th root, so I use my calculator, and it ended up being 1.048. So then when I write my equation, I'm going to say y equals $1.50 times 1.048 to the x. Problem 35, find the inverse. So for these equations, I flip x and y and then solve for y. So I get x equals 1/3 y plus 2. Subtract 2 from both sides. So I get x minus 2, 1/3 y. I'm going to multiply both sides by 3. So I distribute it. So I end up with y equals 3x minus 6. 36, again, I'm going to flip x and y. So x equals 3y plus 2 squared minus 7. I'm going to add 7 to both sides. So I divide both sides by 3. So I get x plus 7 divided by 3 equals y plus 2 squared. So I'm going to take the square root of both sides. So I get plus or minus square root of x plus 7 over 3 equals y plus 2. I'm going to subtract 2 from both sides. So my final answer is y equals -2 plus or minus the square root of x plus 7 over 3. And my last set of problems is to solve the following rationals. So I could put it over 1 and cross multiply, or multiply by 3, it's up to you. So this, if I cross multiply, I end up with 3x equals x plus 6. Subtract x from both sides. I get 2x equals 6. Divide by 2, so x equals 3. This one, I can't cross multiply, so I'm going to multiply everything by 6. So basically it's 6 groups of 2x plus 3 over 6 plus 6 over 2 equals 6x over 2. So if I simplify it, these cancel. I get 2x plus 3 equals 3x. Subtract 2x from both sides. 3 plus 3 is 6 equals x. So my final answer is 6.